Dear students, in the last class, we learnt trigonometric identities. Now we shall use those formulae or the identities to do some applications. The first step is given in exercise 8.3 of your textbook. Express the trigonometric ratios sin A, secant A and tan A in terms of cot A. This is your question. So solution, the trigonometric ratios of sin A, secant A and tan A, these you must find in terms of cot A. So first one is, if I consider from the reverse, tan A is simply 1 by cot A. So that is complete. Tan A expressed in terms of cot A. Second one is secant A, I must express this in terms of cot A. Secant A is equal to square root of 1 plus tan square A, because 1 plus tan square A is equal to secant square A. If I get secant A, square root of this. This is equal to square root of 1 plus 1 by cot square A, because tan is 1 by cot, is equal to square root of cot square A plus 1 by cot square A, and you cannot leave it like this. It is 1 plus cot square A by cot A. That's all. So this is how you can find secant A in terms of cot A. And third one, this is the identity here, this is the identity used. Third one is a sin A. How do you get sin A in terms of cot A? Sin A, it is 1 by cosecant A. You know 1 plus cot square A is equal to cosecant square A. So cosecant A will be square root of 1 plus cot square A. This is how you can express tan A, secant A and sin A in terms of cot A. You can express all the other ratios also in the same way. This is how you can apply the formulae or identities. The same sort of a sum is given in worked out example number 9. And in the worked out example number 9, you have to express cos, tan and secant in terms of sine. Of course, I will do it here. Example, this is page number 34 and sum number 9. This is worked out example. Let express the ratios cos A, tan A and secant A in terms of sin A. Now you have to find cos, tan and secant in terms of sin A. So first write cos A. And you know cos square A plus sin square A is equal to 1. Therefore cos A, as already I told you, cos you can write as square root of 1 minus sin square A since this. So first is complete. And the second one, I must write, whenever I get a square root, I should write plus or minus. Right? And secondly, this I will not write because you need not write it at this stage. Tan A. Tan A, how do you write tan A in terms of sin A? Tan A is equal to sin A by cos A is sin A by cos A is equal to again square root of 1 minus sine square a. So square root of 1 minus sine square a. Right, so tan a is complete. Next is secant a. And secant a is 1 by cos a is simply 1 by square root of so only one identity is used in this sum. It is cos square plus sin square is equal to 1. If you know this, you can express the others easily and you can solve this sum. So this is one model we use to, that is given one ratio, you can find the other ratios. That is what it is. That is in the first sum, in the first exercise. We did suppose some sine is equal to 3 by 5. Find all the other ratios. You are able to find using triangle. Now using this formulae, you can find the other ratios, right? The next is important are the other identities. That is similar identities. You can reduce, prove that. They will be given like prove that. Let us do a very important example. It is worked out in the textbook, but this is very important in the exam point of view. Prove that cot a minus cos a by cot a plus cos a is equal to cosecant a minus 1 by cosecant a plus 1. So you may have a plan, you can practice the sum and do, but in the examination never worry, because in these sort of sums you apply the identities that you know, automatically you will get your answer. Because the RHS is in cosecant, cosecant is sine, 1 by sine is cosecant. So you need to get 1 by sine here. So I will write it as cot theta is cos theta by sin theta, or cos a by sin a, minus leave it as this cos a by cot is cos by sin plus cos a, right? So I can take LCM here and I can proceed. It is differently done in your textbook, so I will follow the same method because this is worked out example. But the easier way is take a sin LCM, cos a minus cos a sin a by cos a plus cos a sin a is cancelled, and further you can get the answer. But let us not do that. Let us continue as given in the textbook. If I take cos a common, 1 by sin a minus 1 by cos a 1 by sin a plus 1, because cos is taken as common, I can cancel this now. And this is equal to 1 by sin is equal to cosecant, 1 by sin is cosecant, minus 1 by cosecant a plus 1, and this is RHS, right? And now whenever you prove an identity, you must always write the answer once again. That is, you have proved cot a minus cos a by cot a plus cos a is equal to cosecant a minus 1 by cosecant a plus 1. You must write the answer. If not, you will lose your marks in the examination. This is one identity we proved. Right? The other sum also very important. Let us prove. This is worked out example number 12. I am writing and explaining because you may have a doubt in doing this. Therefore, I am explaining. These should be done because these are worked out in the exam, in the textbook. You must do them as given in the textbook. No alternative. Right? Don't apply your own methods. Just do what is given in the textbook. So the next is prove that sin theta minus cos theta, sin theta minus cos theta plus 1 by sin theta plus cos theta minus 1 is equal to 1 by secant theta minus tan theta. This is what you have to prove. And here, prove this using the identity secant square theta is equal to 1 plus tan square theta. This you must use. This is very important. Since you want to get the answer in terms of secant and tan, and you must use the identity secant and tan, I must get this into secant and tan first. So take LH first. LHS is sin theta minus cos theta plus 1 by sin theta plus cos theta minus 1. If I want to get tan theta, I need to divide both numerator and denominator by cos theta. So that if I divide, it is, I must write like cos theta, no like this. It is easy if I write sin theta minus cos theta plus 1 by cos theta. I am dividing numerator and denominator by same cos theta. So there is no change in value by cos theta. So this is equal to, you can write it as sin theta by cos theta minus cos theta by cos theta plus 1 by cos theta. Plus 1 by cos theta divided by, that is sin by cos, cos by cos, 1 by cos. Sin by cos, next step is sin theta by cos theta. This plus I write here, cos theta by cos theta, minus I write here 1 by cos theta. So this is equal to sin by cos is tan theta, cos I can cancel, this is 1 by cos theta is secant theta by sin by cos is tan plus 1 minus secant theta. So this is what you got. Now I want to get in terms of, you must prove it as secant and minus tan. Secant minus 1 by secant minus tan I should prove. So what I would do is this 1, that is secant theta plus tan theta minus 1 by tan theta minus secant theta plus 1. You multiply numerator and denominator by the same tan theta minus secant theta by tan theta minus secant theta, so that there is no change in the value. So I multiply numerator and denominator by tan theta minus secant theta. So how much, what would you get here now? This is, you can now check it like tan plus secant into tan minus secant, a plus b into a minus b, a square minus b square, that is tan square theta minus secant square theta, because tan plus secant or secant plus tan, tan minus secant, a plus b into a minus b, a square minus b square. So when I multiply these two, I will do one thing. Let us elaborately write, this is equal to, this is equal to tan plus secant into tan minus secant minus 1 into, this is 1, tan theta minus secant theta by what would be the denominator? Tan minus secant plus 1. I am not expanding this. Tan minus secant plus 1. Simply write it as it is. Don't change this. This is a technique you must remember. This equal to, you will get it as tan square theta a plus b into a minus tan square theta minus secant square theta minus tan theta minus secant theta divided by the same thing you write again, tan theta minus secant theta plus 1 into tan theta minus secant theta. Don't change the denominator. This is equal to, if I take tan square minus secant square, 1 plus tan square is secant square. You know this. 1 plus tan square theta is equal to secant square theta. Therefore, tan square theta minus secant square theta is equal to minus 1. So, this is the numerator will be minus 1, since this is minus 1. You can see this is minus 1. Minus tan theta minus into minus plus secant theta by tan theta minus secant theta plus 1 tan theta minus secant theta. Now what I would do is take minus 1 in the numerator, take minus 1 in the numerator as a common. I get it like 1 minus will become plus, this plus will become minus by tan theta minus secant theta plus 1 into tan theta minus secant theta. Now 1 plus c, you can see now, plus tan minus secant plus 1 plus 1. These two are same. Here this one and here this one. These two are same. So I can cancel these two. I can cancel those two. So how much do you get now? This is equal to minus 1 is left here by tan theta minus secant theta. Once minus is absorbed, it is secant theta minus tan theta. This is what you have to prove. Secant minus tan. So 1 by secant minus tan. Therefore, this is equal to RHS. Therefore, what did you prove? You proved that sin theta minus cos theta plus 1 by sin theta plus cos theta minus 1 is equal to 1 by secant theta minus tan theta. This is how you are able to prove a simple technique. You must remember. You must remember that because you need an answer in terms of secant and tan, we will try to get sine, this numerator and denominator in terms of first tan and secant. Then just simply secant minus tan, numerator and denominator you multiply. This is as given in the textbook. Otherwise you can have a better method. There is a better method of doing this sum. But because this is worked out, I must follow the same method that is given in the textbook. So I multiplied here numerator and denominator by tan minus secant. And then simply, this is application of algebra. And one formula you must use, like 1 plus tan square secant square, or tan square minus secant square is equal to minus 1. If you apply this, you will normally get the answer or RHS, right? This is how you can do this sum. And One more example, you have one more let us do. That is exercise from 8.3. There are sums given in Roman 4, but some are a bit easy. Some I'll do. Fourth sum, third bit. This we have to do. This is prove that 1 plus secant A by secant A is equal to sine square A by 1 minus cos A. A hint is given here. Prove LHS and RHS separately. Right, a hint is given. Even without hint, you can prove, but generally while doing these sums, case 1 is prove LHS is equal to RHS. Sometimes it is easy to prove RHS is equal to LHS. In case these two are not equal, then we prove that first separately simplify LHS and simplify RHS, then prove LHS is equal to RHS. Deduction. So after these three methods in the textbook, third method is followed. That is given as a hint. Prove LHS is equal to some expression or some identity. RHS is equal to some expression. Then the expression obtained from LHS is equal to the expression found from RHS. If you are able to prove, then automatically LHS is equal to RHS. So let us try doing this, separately proving each to be equal to some part, some expression. So consider LHS. What is this? 1 plus sine secant A by secant A. Right. So you have to prove secant A in terms of sin A and cos A. So simply you write 1 plus 1 by cos A by 1 by cos A. This is equal to, take LCM in numerator, and you will get this is equal to cos A plus 1 by cos A. It is LCM is taken. Cos A plus 1 by cos A by 1 by cos A. So this is equal to cos A plus 1 by cos A into cos A by 1. You can cancel this. So this is equal to cos A plus 1. This is how you reduce it. LHS is reduced to this. Now take RHS. RHS given as sine square A by 1 minus cos A. This is sine square A. This is equal to sine square is 1 minus cos square A by 1 minus cos A. This is 1 minus cos square is 1 square minus cos square you can write, or A plus B into A minus B you can apply. So 1 square minus cos square by 1 minus cos is A plus A square minus B square. So 1 plus cos A into 1 minus cos A by 1 minus cos A, and you can cancel. But while cancelling, don't cancel 1 and cos separately. It is a single expression that you have cancelled. So this is equal to 1 plus cos A. Otherwise you can write it as cos A plus 1. So you are able to prove LHS you started and you are able to get it is equal to cos A plus 1. RHS you started, again it is cos A plus 1. So in both the cases it is proved that LHS is equal to RHS. Therefore LHS is equal to cos A plus 1 is equal to RHS. And therefore finally we will write the answer 1 plus secant A by secant A So you can write it as 1 plus secant A by secant A is equal to sin square A by 1 minus cos A. So you are able to prove this by proving LHS and RHS equal to the same separately. This is one method we can use to prove some of the things given like this. This is a method, a new method. So this is an important thing you must remember. And second, next sum is of course fifth sum, which is also very important. Let us do this fifth sum. Cos A, prove that cos A minus sin A plus 1 by cos A plus sin A minus 1 is equal to cosecant A plus cot A using cosecant square is equal to one plus cot square A. Using this, you have to prove this identity. Now the same is given as it is, and I have explained this already in the worked out example number 12. That is sin minus cos plus 1 by sin plus cos minus 1 is equal to 1 by secant minus tan, using secant square is equal to 1 plus cot square. Here again the same sort of thing is given. In the right hand side you have to prove it to be equal to cosecant A plus cot A. Since you have to get cosecant plus cot on the right hand side, we divide numerator and denominator of LHS by sin A. Previously we needed secant and tan, we divided by cos A in the example 12. So start with this. That is, consider LHS. What is it? Cos A minus sin A plus 1 by cos A plus sin A minus 1. So what would you do first? Divide by sin A. So cos A by sin A minus sin A by sin A plus 1 by sin A. Each term is divided by sin A. Here also each term is divided by sin A. Let us not divide. Cos A by sin A plus sin A by sin A minus 1 by sin A. I divided numerator and denominator by the same, that is sin A. Now cos A by sin A is equal to cot A minus, it is given in terms of A. Sin A by sin A is 1. 1 by sin A is cosecant A by, this is cos by sin again cot A plus 1 minus cosecant A. Now you have to use this identity. So don't change the denominator, change only numerator. Otherwise you can, as in the previous case, you can multiply numerator and denominator by the same. So this is equal to cot A minus 1 plus cosecant A by cot A plus 1 minus cosecant A. Numerator and denominator are multiplied by the same here. In the previous case, we multiplied by tan minus secant. Tan minus secant. Let us multiply numerator and denominator by cot minus cosecant. So cot A minus cosecant A by cot A plus cosecant A. Sorry, it is minus. Numerator and denominator must be multiplied by the same, that is minus, right? So this is equal to cot A plus cosecant A. I am writing it like cot A plus cosecant A minus 1 into cot A minus cosecant A divided by cot A plus 1 minus cosecant A, and it is cot A minus cosecant A. This is equal to, you can now check, this is cot plus cosecant, cot minus cosecant. So it is cot A plus cosecant A into cot A minus cosecant A minus 1 into cot A minus cosecant A divided by, don't change, don't multiply or do anything with the denominator. This sort of sums only we multiply or simplify numerator or denominator. You can multiply or simplify numerator or denominator, only one you can. So a plus b into a minus b, a square minus b square, that is cot square a minus cosecant square a minus 1 is taken in, absorbed inside, so it is cos a minus into minus plus cosecant a by cot a plus 1 minus cosecant a cot a minus cosecant a, and 1 plus cot square is cosecant square, so cot square minus cosecant square, how much? Cot square minus cosecant square is minus 1. It is minus 1, so it is minus 1 minus 1 minus cot a plus cosecant a by cot a plus 1 minus cosecant a into cot a minus cosecant a. This is equal to, if I take minus common, 1 plus cot a minus cosecant a by, I'll change the denominator also, I'll write it like 1 plus cot a minus cosecant a. Same thing, I just changed the terms, order of the terms, and this is cot a minus cosecant a. And this I can cancel. So this is equal to minus 1 by cot a minus cosecant a. What should you prove? You should prove that is equal to cosecant plus cot. Cosecant plus cot. So minus 1 again is written as 1 plus cot square is cosecant square. I'll write it here. 1 plus cot square is equal to cosecant square. So minus 1, how do you get minus 1? Cot square minus cosecant square. Cot square a minus cosecant square a. This is equal to cot square is taken, it is minus 1. So minus 1 is written like this, by cot a minus cosecant a. This is equal to again a square minus b square. We write it as cot a plus cosecant a into cot a minus cosecant a by cot a minus cosecant a. And cot a minus cosecant a is cancelled. You get cot a plus a cosecant a. This is equal to RHS. And therefore, finally, we proved What did you prove? You proved that cos A minus sin A plus 1, cos A minus sin A plus 1 by cos A plus sin A minus 1 is equal to cosecant A plus cot A. Right? That's all about it. There are 2 more examples we can prove, but I'll do them in the next class. Thank you.